Hi guys, Dr. B here. This is your lecture on percent composition. It is the percent by mass of each element in a compound. The percent composition of a compound can be determined from its formula and the molar masses of the elements that make it up. So you have to know your molar masses and recognize how to get them, etc. by looking at the periodic table. So how do you calculate it? You calculate the molar mass of the total compound, and then from there you can get the mass of, so from there you actually get the mass of each element as well. Divide the mass of each element by the molar mass of the compound and then multiply by 100. So it's pretty easy actually. Here's the formula. The percent of an element equals the mass of the element in 1 mole of the compound. So basically just getting it from the periodic table divided by the molar mass of the compound, which is the sum that you already know how to determine. You multiply by 100. When you know the percent of a compound when you know your percent composition and you're trying to find a specific element, if you will, you can calculate the amount of that. So for example, well, I'll show it to you in a second. How about that? Calculate the percent composition of CO2, carbon dioxide, and then determine the mass of carbon in 35.0 grams of carbon dioxide. So for the first part, cool. All right, so the percent composition. So part 1. So the percent of C and the percent of O of each element, not necessarily O2, but just the percent of carbon in this. So it's going to be 12.01, which is the molar mass of carbon. You're going to divide it by the total molar mass of carbon dioxide, which is 12.01 plus 2 times 16, so 44.01 times 100. So then for oxygen, it's just 32 because it's O2, 16 times 2, divided by 44.01 times 100. Then you get your numbers. So 27.289, we can just do whole numbers, it's fine. So percent, 27%. 32 divided by 44.01, oops. This is going to be 73%. So when I multiply by 100, I got 72.710748. So just round up to the nearest whole number. Yes, if you're wondering, you could have subtracted the carbon from 100 to get 73. However, you need to be careful because if you mess up on one, you'll get the wrong answer on the second one, then both will count against you. Also, well, I'll show you an example in a little bit, what I'm about to say. Determine the mass of carbon in 35 grams of carbon dioxide. So you're going to take, this is number 2, 35.0 grams times the decimal form of your percent. So it would have been 0.27. So 35.0, so 3 sig figs times 0.27. So 9.45 grams of carbon. Calculate the percent composition of ionic compounds that contain polyatomic ions. Be careful because notice you have a lot of parentheses and you have a lot of different things. So we have for each element, so we have percent of nitrogen, percent of hydrogen, percent of phosphorus, and percent of oxygen. So before we can get started, we have to get the total molar mass of this. for our denominators, or I guess denominator. So it's 3 times 14.01, that's nitrogen, 12 times 1.008, I'm sorry, for hydrogen, plus 1 times, where is it at? 30.09. You can't see that. 97, and then 4 times 16. Got to get the sum of all of that. So the total molar mass of ammonium phosphate, so we have 3 times 14.01 plus 12 times 1.008 plus 30.97 plus 16 times 4. Yep, so about 149.096. So my numerators are just going to be the masses for each of these. So phosphorus is going to be 30.97. 16 times 4 is 64. 12 times 1.008, 12.096. 14.01 times 3. 42.03 divided by 149.096. This is going to be kind of running out of space. Can't see that. 28%. .11, so 8%. 30.97 divided by 149.096. This is going to be approximately hold on, there's some delay. Hold on. .21%. Then 64 divided by 149.096. 43%. Let's double check these all equal 100. So 28 plus 43 plus 21 plus 8. Good, should equal 100%. So what I was saying earlier, you have to be careful that let's say you do N and H, but you see PO4, you just put them all together. Do not do that. It's per element. So technically here there are 4 different types of elements in this compound. So just be careful. Also, you can't just do N and H and then subtract from 100 to get PO4. That's not how it works. All right, so if you have any questions, please let me know. Thanks.